Alright, so in this video, I'm going to solve the equation x to the power of 4 minus 33x minus 10 is equal to 0. And obviously, I want to find the value of x here. So now for my solution. At first glance, a lot of people think we can just solve this using the quadratic formula. But notice here how we have x to the power of 4 instead of x to the power of 2. If this was a 2 instead of a 4, we could use the quadratic formula and easily solve this. But because this is to the power of 4, we can't do that. This isn't a quadratic equation. So what I'm first going to do, let me rewrite my equation down here real quick. I'm going to add 33x and 10 on both sides. So now I have x to the power of 4 is equal to 33x plus 10. And now, I'm going to add am squared plus b on both sides. So I have x to the power of 4 plus am squared plus b is equal to am squared plus b plus 10. And this is the same thing as x to the power of 4 plus am squared plus b is equal to a times m squared plus 33m over a plus 10 plus b over a. And what we're doing here is we're making a perfect square on both sides, meaning 1/2 of a squared is equal to b, so a squared over 4 is equal to b. So this is the relationship. So in this case, 1/2 times 33 over a squared is equal to 10 plus b over a, meaning 33 squared over 4a squared is equal to 10 plus b over a. So 33 squared is equal to 40a plus a to the power of 3. So now from here, I have a to the power of 3 plus 40a minus 1089 is equal to 0. So now we turn this to a cube. And to solve this, I'm going to rewrite this as a to the power of 3 plus 40a minus 729 minus 360 is equal to 0. And this turns into a to the power of 3 minus 9 to the power of 3, which is the value of 729, plus 40a minus 360 is equal to 0. And 360 is the same thing as 9 times 40. So, if I have something in the form x to the power of 3 minus y to the power of 3, this is equal to x minus y times x squared plus xy plus y squared. So a to the power of 3 minus 9 to the power of 3 turns into a minus 9 times a squared plus 9a plus 9 squared, which is 81. And I have this plus, I can factor out 40 from this, so 40 times a minus 9. So now I get a minus 9 times a squared plus 9a plus 81 plus 40, which is a minus 9 times a squared plus 9a plus 121. Now this gives me two equations. I have a minus 9 is equal to 0, and a squared plus 9a plus 121 is equal to 0. So for a minus 9 equals 0, I get a equals 9. And for a squared plus 9a plus 121 equals 0, well, let's first find the value of b squared minus 4ac. Because the value of b squared minus 4ac is less than 0, then this means that we can't use the solution. So the value of b squared minus 4ac is 9 squared minus 4 times 1 times 121, which is less than 0. So there's no solution here. Now, recall that b is equal to a squared over 4, meaning b is equal to 9 squared over 4, which is equal to 81 over 4. So this is the value of b. And now, recall, because we're solving for x, not for a or b, m to the power of 4 plus am squared plus b is equal to am squared plus 33m plus 10 plus b. So this was where we added am squared plus b on both sides. So now we're going to plug the values of a and b here. So I get m to the power of 4 plus 9m squared plus 81 over 4 is equal to 3m squared plus 33 times 11, 3m times 11 plus 121. And now this turns into m squared plus 9 over 2 squared is equal to 3m plus 11 over 2 squared. Meaning m squared plus 9 over 2 squared minus 3m plus 11 over 2 squared is equal to 0. Now, if I have something in the form x squared minus y squared, this is equal to x plus y times x minus y. So this turns into m squared plus 9 over 2 plus 3m plus 11 over 2 times m squared plus 9 over 2 minus 3m minus 11 over 2 is equal to 0. Meaning m squared plus 3m plus 10 times m squared minus 3m minus 1 is equal to 0 if we simplify this. So I have two equations, m squared plus 3m plus 10 equals 0, and m squared minus 3m minus 1 equals 0. So if you solve this for b squared minus 4ac, this is going to be less than 0. And for this one, it's going to be 9 plus 470, which is greater than 0. So I can use the quadratic formula to solve this. So I get m is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, a is 1, b is negative 3, and c is negative 1. So I get m is equal to negative of negative 3 plus or minus the square root of negative 3 squared, which is 9, minus 4 times 1 times negative 1 all over 2 times 1, which is equal to 3 plus or minus the square root of 9 plus 4 over 2, which is equal to 3 plus or minus the square root of 13 over 2. So my two solutions of m are 3 plus the square root of 13 over 2 and 3 minus the square root of 13 over 2. So these are my solutions. Thank you for watching, and please make sure to subscribe.